Hello everyone, myself Jyoti Kattige, Assistant Professor ENC Department, PGMIT Mudok. Today I will do the experiment of second order low pass filter using 741 op amp. The aim of the experiment is design the active second order Butterworth low pass filter using a 741 op amp. The circuit diagram for this one is shown in figure here. Here we are using the 741 IC in the non-inverting mode. Here it is a second order Butterworth filter, therefore we are connecting two pairs of RC, that is R1 C1, R2 C2. Here C1 and C2 we have taken the same values as 0.1 microfarad, R1 and R2 as 2 kilo ohms, R3 as 10 kilo ohm, and R4 the feedback resistor between pin number 2 and 6, 10 kilo ohm. Output we are measuring across the pin number 6 in the CR. Next, input is given to the resistor R1, one end of the resistor R1, that is through the function generator. We have kept here 2.2 volts peak to peak. After doing all these calculations, we need to measure the output at the CR. For this, the cutoff frequency I have taken as 1 kHz. The input frequency I kept as 2 volts peak to peak. By varying the frequency 8 Hz, 800 Hz, 900 Hz, 950 Hz like this, since the cutoff frequency is 1 kHz, around 1 kHz you need to take more frequencies, then measure the output at the CR. Here I have taken the readings for by varying the frequencies, that is output voltage for 800 Hz we got it as 1.9 volts. Similarly for 900 Hz 1.8. We have to measure the output voltage by varying the input frequency. Here I have varied the frequency from 800 to 4 kHz. Around 1 kHz I have taken more frequencies. Then you need to measure the gain. Now you are knowing the value of output voltage and the input voltage. You need to calculate the gain. That is, gain is equal to output voltage by input voltage. Next, gain in dB you have to calculate, that is 20 log of output by input. From the CRO you have to take only the output voltage, the remaining calculations you have to do by yourself. Next thing is how you will get the waveform for this. The waveform for the low pass filter is shown in figure here. Here we are drawing the graph across frequency versus the voltage gain in dB. First, for the lower frequencies, the output voltage will remain almost constant. After the cutoff frequency FH, the output voltage goes on decreases. Therefore, between this, for lower frequency it is a pass band, for the upper frequency after cutoff frequency it is a stop band. Since it is a second order low pass filter, there will be decrease of minus 40 dB per decade in the stop band. This is explanation regarding the second order Butterworth low pass filter. The same connections I have done here. See here. By varying the signal generator, here I use the signal generator, the DC power supply, then the CR. For input as well as output you have to see in the CRO waveform. Here I have done the connections for this experiment. Op amp I have used two 10 kilo ohm resistors, two 2 kilo ohm resistors, and the capacitor 0.1 microfarad capacitor. Next, here 12 volts I have kept, plus 12 volts for the pin number 7, minus 12 volts for the pin number 4. Next, signal generator, you need to vary the frequency. Here I kept for sine wave, and here you are getting the output waveforms. Suppose see here, if I kept the input frequency as input frequency, I will vary here. Suppose if we'll keep 1 kilohertz, here the frequency also varies. Okay, first one is the input voltage, okay, second one is the output. If we'll vary this one frequency according to the low pass filter, first it has to remain constant, then it should be decrease. If we are varying the frequency after 1 kilohertz, it goes on decreasing. See here it is decreasing. I am increasing the frequency. The frequency is now 2 kilohertz, okay, for this waveform. Okay, this is about the low pass, second order low pass Butterworth filter. Thank you.